Dear all, welcome to Civil Services with ZAKI. Today we are going to discuss about the oldest black hole in the universe, and as you know it is related to the prelims exam 2024 and specific science and technology. So this is very significant topic. So let us see why this topic is significant. So see why this topic is significant. So it is significant because this black hole is 13 billion year old, and another is, if you see, it is a few million times the mass of the sun. So it is big supermassive black hole, and also it is eating its host galaxy to death. So it's incredibly eating their host galaxy. It's also puzzles among the astronomers and scientists. And another is, it is accreting matter at the rate of 5 times higher than the Eddington limit. So we also discuss about the Eddington limit. Basically, Eddington limit is the limit in which rate black hole accrete the matter. So let's talk these topic. So today's let's see this see what are the today's subtopic. So today's subtopics are: number one, first we see the animation of the oldest black hole. As you know, the animation of the oldest black hole, and also the James Webb Space Telescope, a time machine. So new era began with the installment of the James Webb Telescope. If you want to and want detailed explanation or about the James Webb Telescope, then you can watch my this video, James Webb, a specific video on James Webb Telescope. So it is a time machine. Another is about the cosmic dawn. So what is the cosmic dawn? We also discuss about it. And also compact galaxy GN-z11. So what is the GN-z11 and compact galaxy? Basically this is the oldest galaxy. It is the oldest galaxy in our universe. One of the oldest galaxy in our universe. It is about 13 billion year old, more than 13 billion year old. Also the hungry black hole and dying galaxy GN-z11. So basically these black hole accreted very fastly and consume matter of this galaxy is so fastly, it may be the in near future this galaxy may be die soon. Another is supermassive black hole, a cosmic mystery. So basically how these type of the supermassive black hole, basically all galaxy, major galaxy like our Milky Way contain supermassive black hole. That's why scientists and astronomers want to know why this type of the supermassive black hole in the center of the galaxy, and what is the process the making of the this type of the supermassive black hole. Also we see the standard model of the supermassive black hole, basically the theory regarding the creation of the supermassive black hole. We also see this standard of the another is, if you see the solving puzzles of this black hole. So this black hole basically defy the standard model of the creation of this supermassive black hole. So what are the possibles for the creation of this oldest supermassive black hole in the universe? And another is a new era, the giant leap in the sensitivity. So what is the sensitivity? Basically sensitivity in the telescope like the James Webb Telescope and other future telescope. And as you know, this is also very significant to know about the most probable question for the civil services examination. So we also provide mega question for UPSC-CSE 2024 and, as you know, 2022, 2023, about 20 plus question directly asked from this video and our blog. So follow my blog and subscribe my channel. So let's start with the context. What are the context? So see here, if you see the context, James Webb Space Telescope, as you know, has spotted the oldest black hole ever seen in. Basically, it is incredibly ancient black hole and challenging the astronomer to explain how it could be exist only 440 million year after Big Bang. So the black hole date from the dawn of the universe. So we also discuss about what is the dawn of the universe. So basically this black hole existed from the dawn of the universe, and found that it's eating its host galaxy means GN-z11 to death. So discovery could be helped. So why this discovery is very significant? Because it could be help how today's supermassive black hole, including our own black hole, Milky Way galaxy black hole, grow such mind-blowing size. So basically this research published on 17th January in the journal Nature. So it is very latest news. So this black hole is the oldest black hole right now. So let's see the animation. As you know, the our animation. So see today's animation. So if you see here, basically these black hole are found in the northern hemisphere, basically in a northern patch of the our sky. So basically, as you see, this galaxy, the hosting galaxy of this black hole is called NZ11. The galaxy is seen as 13.4 billion year in past. So if you see this galaxy you see in the past 13.4 billion year in the past. So see here, see here, see here, this is, as you see, the northern sky. Here, if you see here, see here, in the northern sky you can find this is called Big Dipper. So basically Big Dipper is the part of the Ursa Major. So see here, 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 here. It is the situated near the constellation Ursa Major. So see here, see here, Ursa Major. So if you can zoom these area, and you find a unique patch of the galaxies. Basically these are the oldest galaxy of our universe. Basically these area are called Coots North Field Galaxy. So if you see this galaxy name is GN. So G means good, N means north galaxy, and Z small is the redshift. So basically these area, if you see here, if you see here, if you see here, here, filled with the oldest galaxy in our universe, and one of these oldest galaxy is GN-z11. See here, see here, see here, see here. So this is GN-z11, and basically it is only formed after 400 million of the Big Bang. So if you see here, here, so previous record holder is, if you see here, previous record holder is GN-z8, and no GN-z11. It is the now oldest galaxy. It is previous record holder. So these area basically called reionization area, and reionization area is also called the cosmic dawn. Dawn. It is also called cosmic dawn, and this area is called dark age. So astronomer and scientists don't know much about the dark age era. Basically it is formed after the Big Bang. So this area is called cosmic dawn, and these galaxies situated in the cosmic dawn. So that's why it is one of the significant. So if you see here the Hubble telescope, basically this galaxy is discovered by the Hubble telescope, and black hole discovered by the James Webb Space Telescope. So let's see here, see here, James Webb Space Telescope. It is James Webb Space Telescope. As you know, our video, a specific video on James Webb Space Telescope. So this black hole discovered. So this black hole situated near the dawn of the our universe. See here, see here. It means you can see this black hole from the from the down of the universe. So it means this oldest black hole maybe have clue how these type of the supermassive black hole form, and why this reionization area, and also unveil the some of the important thing about these reionization area or the dawn of the universe, as you know, and the Big Bang theory. And we also answer question some how James Webb Space Telescope detect these type of the black hole, such type of the oldest black hole. So we will also answer why this black hole, supermassive black hole, existed only 400 million after the Big Bang. So we also discuss all these things, so stay with us till the end of video. So see here, basically these black hole, this oldest black hole discovered by the James Webb by the two camera. One camera is called MIRI, we will discuss in the later on, and also NIRCam. These two infrared camera data of these two infrared camera used by the James Webb telescope, and the scientific and scientist and astronomer use the basically gravitational lensing. So basically these data prepared by the gravitational lensing. So basically gravitational lensing is the bent of light due to the high gravity of the galaxies. So like the normal lens, these galaxies are bend the light due to the gravity. So it's magnifying the galaxy background. That's why it's easily to capture the background image. So see here how, see here is this type of, see here, see here, see here, see here, see here, see here. So basically these gravitational lensing used to detect this supermassive black hole oldest. And finally, the analysis of the precise data, it is calculated that the accretion disk and basically event horizon of this black hole is accreting mass very fastly, 5 times of the limit of the and basically it is 1.6 million times older. Mass is greater than the sun, 1.6 million times, and also 5 times at the Eddington rate. So basically this Eddington rate is the highest limit of any black hole accreted matter from the galaxy. So it means these matter highly consumed by this black hole. It means this infant galaxy soon die, because this galaxy is 100 times smaller than our Milky Way galaxy. So it maybe soon die, and unfortunately the galaxy die, it means black hole also die due to the matter supply of this matter. So let's see in detail James Webb telescope, a time machine. So why? Because the James Webb telescope, whose camera enabled to look back in the time of our universe beginning, so spotted a supermassive black hole at the center of the infant galaxy GN-z11 just 440 million years after the universe began. So it's one of the oldest galaxy. Also, this black hole is the oldest black hole ever seen, and this ancient monster with the mass of 1.6 million suns, about 13 billion year in the universe past. So basically it is lurking about the 13 billion year into the universe past. So spot this black hole, the astronomer scanned with sky with two infrared camera. So basically astronomer use infrared camera, and these two infrared camera is one mid infrared camera MIRI, and another is near infrared camera or NIRCam. So if you want to know more detail about NIRCam, infrared camera, etc., then you must watch our specific video on James Webb telescope, this video. So in this video you can find everything about the James Webb telescope. So let's we move forward and see about the cosmic dawn. So what is the cosmic dawn? Because these black hole found near the cosmic dawn. So basically, if you see, the one of the most important gap in our understanding of the universe history, if you see the universe history from the beginning of the inflation and all that dark age and dawn, universe cosmic dawn. So basically, cosmic dawn is the period of about 50 million years to 1 billion years. So basically, after the Big Bang. So if you want to know more about the Big Bang and all that, then you must subscribe our channel, and I hope our students are also know about our class and also the Big Bang. We discuss detail about the Big Bang, how George Lemaitre and Alexander Friedman proposed this theory and all that. So when the first star, first black hole, basically this period is the period when the first star, first black hole, first galaxy in the universe formed. So it is the beginning of the universe, or you can say the beginning of the visible lights. So just like that, if you wake up in the early morning before the sunrise, it's called dawn. So that's why it is called cosmic dawn. Before the cosmic dawn, it's a dark period, so it is also called dark age. So let's move forward and see. This is the cosmic dawn. These area are called cosmic dawn. 50 million to 1 billion. Between these area, from darkest to, it is called reionization area or cosmic dawn. So it is called reionization era or cosmic dawn. If you more refine this and situation of this new black hole, you can see this. This is called dark age, cosmic dark age. So after the maybe first star formed here and etc, but it may be in the future our James Webb telescope and other high powerful telescope will detect the first star and all that. So this is the oldest galaxy. It is GN-z11. It is the farthest galaxy seen by Hubble and farthest black hole and the oldest black hole seen by James Webb Space Telescope. Previous record holder is this. So this is Big Bang, this is inflation period, and this is cosmic dark age, and this is called reionization era, or it is also known as cosmic dawn. It is also known as cosmic dawn. So let's move forward, and I hope you understand about the cosmic dawn. So let's the compact Galaxy GN-z11. So what is context? So GN-z is a compact galaxy about 100 times smaller than our Milky Way. So GN-z was discovered in 2015 by the Hubble telescope. The name GN and Z come from the location. As we see in the animation, these area called Goods North, and as you know, it's near the Ursa Major constellation. So field of the galaxy, basically it is the high cosmological redshift number. So if you see this patch of the sky, you can find a high redshift area. So basically this redshift area and specific this galaxy has high redshift number, and it's called Z11. Z is the denoted basically the redshift. So redshift 11. So it is called, then why it is called Goods North GN, and Z means redshift 11. So that's why it is called GN11. It's about 32 billion light years from our Earth. So this galaxy is 32 billion light years from our Earth. So we see the hungry black hole and dying galaxy GN-z11. So basically, a black hole is likely to harming its development when black hole consume much gas. So these black hole consuming more matter, more gas and etc. So it pushes gas away like ultra fast wind, and basically this wind could stop the process of star formation, so slowly killing the galaxy. So finally this process killing the galaxy, but it also killed the black hole because it was because it would also be cut off the black hole from the source of food matter. So if no matter is present, it means no matter for the black hole. It means finally this black hole will also die. So we also see why this type of the supermassive black hole formed. So basically this supermassive black hole a cosmic mystery. So why it is cosmic mystery and puzzles among the astronomers? Because astronomer believe supermassive black hole found at the center of galaxy like us Milky Way grow their current size over billions of years. So basically astronomer believe a black hole formed in the remnant of the dead star, which is 100 times greater than the sun, and after the accretion of the matter it will be it will be take billions of years to form the supermassive black hole, like the millions or billions times of the sun. So the size of this newly discovered black hole suggests they might be form other way. So it is not form this way, other way. It might big ball, and they can eat matter that's 5 times higher than the possible limit. So it is limit is called Eddington limit. Eddington limit is the accretion limit of any black hole. So Eddington limit is 5 times greater than the Eddington limit. So it's also a puzzle for the scientist. So it's mystery. So if we see also the standard model of the supermassive black hole, and scientists assume or believe that if you see according to the standard model, supermassive black hole form the remnant of the dead star, which collapse and maybe black hole but about 100 times mass of the sun. So this type of the black hole need a star which is 100 times greater than the sun mass. So grow expected way, and this new and after 100 times they grow in the billions of years in the such type of the millions time or 1.6 billion. That's this black hole is 1.6 million mass of the our sun. So if grow unexpected way, this newly detected black hole would take a billions of years to grow to the observed size. But here is, if you see, the universe was not yet a billion year old when this black hole detected or this black hole formed. Universe at that time only 400 million year old. So that's why this black hole formed. It is a big question. So scientists basically solving these puzzles of the black hole and propose 3 main possibility of this black hole. Listen carefully, these 3 possibility. Number 1 explanation is known as heavy seed scenario. So basically it is heavy seed scenario. So what is heavy seed scenario? It's an early generation black hole born from direct collapse of vast cloud of the gas. As you know, after the Big Bang, vast cloud of the gas and dust spread across the universe. So rather from burnout is a star, it's collapse under their own gravity at the end of their life. Another possibility is, if you see, second possibility is the compact cluster of star and black hole, and basically its compact cluster of stars and black hole merge very rapidly in the early universe. If you see the early universe, a star is the greater very big stars. It means it's 10,000 times greater than our sun. If you see the current star, the biggest star is only 1,000 times of our sun. But in the early universe, the star basically a star was about 10,000 times greater than our sun, and also some black hole also present. So scientists believe second possibility that the compact cluster of these stars and black hole merge very rapidly in the early universe. It is the second scenario. And the third scenario is most basically, if you see the most speculative hypothesis, is the existence of so-called primordial black hole. So primordial black hole, what is primordial black hole? Basically it came into existence during the cosmic inflation. And it is what is cosmic inflation? As you know, cosmic inflation is the period of faster than light expansion of the universe. So at that period universe expand faster than the light. So it occurred about the fraction of the second after the Big Bang. So if you see the Big Bang, and after that Big Bang, it's fraction of the light, and then finally, so this period is called inflation. So at that period maybe some primordial black hole present at that time. So it's also possible. So this theory is also one of the significant theory of the formation of this new discovered black hole. It may be soon we in future see this type of the primordial black hole, which is maybe older than this black hole. So let's see another, a new era, the giant leap in sensitivity. So what is sensitivity? Basically this sensitivity is the advancement of the telescope. So see here, according to the scientist, it is a new era, a giant leap in sensitivity, basically infrared telescope, basically like the upgrading from the Galileo telescope to the modern telescope overnight. So from the Galileo to the modern telescope, it means 400 years or approx 400 years overnight. So as you know, the advancement of technology and increase all these things may soon be very easier to everybody or every scientist and astronomer. And finally we know about the other oldest black hole in the future. So if we see in the future observation of the James Webb Space Telescope and other future telescope like the Carl Sagan telescope may be the successor of James Webb telescope, and it may be deployed in 30s or maybe mid 30s or 40s in this century. So it's uncover the black hole seed theory, and also it means GN-z may not be the oldest black hole for a long, maybe 1 year, 2 year, or maybe 3 year, and other discovery maybe this black hole is the second oldest and other thing. So but anyhow, present day or after completing this video, this black hole is the oldest known black hole in our universe. So let's significance of this topic, because as you know, in several years like the black hole, gravitational waves, LISA, STC, various times asked by the civil services examination UPSC, whether it is 2022, 2023, 2019 and etc. So that's why this video is very significant for you. So let's see 5 mega question for the UPSC. So one question is basically the shape of this oldest galaxy, and also age of the oldest black hole, and also what is the cosmic dawn, as we discussed earlier. So another is, if you see the basically the meaning of the G and Z, what is the meaning of this, and also according to the supermassive black hole, standard model of the supermassive black hole. So please, so these all five questions are very significant for you for the civil services examination. For this, you go to our description box, and please go to the description box and see the detailed answer. We will provide all these questions, and finally you join our this group, and you can find each and every question in this group in our daily weekly Saturday class of the current affairs. In this class we provide you basically a PDF of this current affairs, and also the answer of today's video, and all weekend question and answer. And also if you see and find in group question of the day, is also very significant like this, if you see here. So that's why please subscribe our channel, tell your friends and colleagues, and don't forget to subscribe our channel. And also if you want to contribute and donate us, please help us and scan this. So anyhow, thanks for watching this video. Thanks a lot.